Okay, so now we're going to talk about graphing because that's what these units involve. So basically, we start with Module 11, which involves graphing a line. Now, just an overview of the unit. All right. All right. When we graph, we have quadrants. Quadrant 1 is where both are positive. Quadrant 2 is where the x is negative and the y is positive. Quadrant 3 is where both are negative, and quadrant 4 is where x is positive and the y is negative. X is your horizontal. Think of it as a number line. Y is your vertical. Think of like a temp of a thermometer. Positives are up, negatives are down. Okay, now when we are plotting points, each point has two coordinates. The x comes first, the y comes second. Every single point. All right, so when we talk about the y-intercept, realize it also has an x coordinate. All right. And you can see in the details for the Module 11 hints, the tool you're going to use to graph. So make sure you pay attention to that. All right. Now, when you are explaining in the real world, what we're looking at is basically, all right, when we're looking at that in the real world, format is y equals mx plus b for the most part. All right. M is some type of rate. B, which we'll also call the y-intercept, is your starting point. All right, it's some type of constant. So if you start with $80 and then make $24 an hour, y equals 24x plus 80. All right, because 24 is the rate, 80 is your starting point. All right, now when you are graphing these lines, whether it be abstractly in the algebra world or in the real world, all right, what we basically do, all right, is, all right, y equals mx plus b. We start at b. Like we said, it's called our y-intercept. Its coordinates are 0 and b. So if you have to graph y equals 2/3 x plus 4, all right, you're going to start at 4 on the y-axis. And then this is what we consider slope that we'll talk about in these modules. The numerator is how much you go up or down. The denominator is how much you move to the right. All right, so from the 4, I'm going to go up 2 and over 3 and plot that point. And then connect to form your line. All right, so that is how we graph lines for the most part when it's in y equals mx plus b system. Now, when it's in what we call standard form, it's a little different. All right. When it's in standard form, looks like ax plus by equals c, and we're going to graph it using what's called the intercept method. All right, and what we're going to do is we're going to divide c by the coefficient of the variable. All right, so if we have 2x minus 5y equals 10, all right, basically to get the x-intercept, we're going to take 10 and divide by the coefficient of x, which is 2. So 10 divided by 2 would be 5. So on the x-axis, we're going to plot 5. That would be 5, 0 if we're plotting the point. We're then going to do the same thing with the y, dividing it into 10. But this time we're going to divide by the negative 5. Positive divided by negative is negative. 10 divided by 5 is 2, so negative 2. So I would plot that at negative 2, 0. All right. And then I would graph those two. All right. So that's how I graph in either format. All right. Now when I'm looking at M12 and trying to calculate the slope, all right, there's a lot of different things we can use for slope. All right. There's a lot of different things we can use for slope. All right. We can think of it as the change of y over change in x. y2 minus y1 over x2 minus x1. All right, are two of the common things we think of. All right, when we're graphing a line, it is what is called m. So y equals mx plus b. All right, that is your m, either one we think of. So if we have 2 points, 2, 8, all right. To make it bigger so it's better, more visible for everybody. So if I'm going to think of 2, 8, all right, and 5, 4, and I want to get that slope. All right, now you can start with either one. We'll show you that in a second. But if we start with the 5, 4, we take the y coordinate, which is 4. We put it on top of the x coordinate is 5. We automatically put minus signs up. All right, and then we take the second point and subtract it. So that would be an 8, and that would be a 2. 4 minus 8 is negative 4. 5 minus 2 is 3. So the slope would be negative 4 over 3. Oftentimes, all right, when one of them is negative, we think of the slope as all being negative. So the slope of that would be negative 4 over 3. All right. Now, as you progress, obviously, sine numbers that we dealt earlier in the year are going to be huge. All right. So if I'm looking at, let's say, 7, negative 1, and negative 3, 6. All right. There is no rule that says you have to start with the second point. We can also start with the first point. All right. So if I started with the first point, negative 1 over 7, minus, minus, and then that would be 6 over negative 3. Remember your sine number rules. Negative 1 minus 6 becomes negative 1 plus negative 6, which is negative 7. And 7 minus negative 3 turns into 7 plus 3, which is 10. So once again, we would have a negative slope of negative 7 over 10. Now, if I switch the order like I talked about, all right, if I switch the order like I talked about, and I started with the second point first, so 6 and negative 3 minus minus negative 1 over 7. 6 minus negative 1 turns into 6 plus 1, which is 7. Negative 3 minus 7 turns into negative 3 plus negative 7, which of course gives me negative 10. And if I pull the negative out, like I talked about before, you'll see that the two values come out to be exactly the same. All right, the last thing I want to talk about is the role of 0 with slope. Okay. And that would constitute horizontal and vertical lines. All right. So if we have a horizontal line, all right, the slope is 0. That's because if I pick 2 points, let's say this was 1, 3, and this was 8, 3, and we did slope, 3 minus 3 would be 0 over 7. 0 divided by anything is 0. So a horizontal line, the slope would be 0. Vertical line's completely different. Vertical line, let's say we went from 1, 6 to 1, 9. Now we would do 9 minus 6 over 1 minus 1. 9 minus 6 is 3. 1 minus 1 is 0. And we can't have that. We can't have a 0 in the denominator. So for a vertical line, we say the slope does not exist or it's undefined. All right. I think that covers just about everything. What's in there? There are a couple other things. Graphing inequalities. When it's solved for y, you're gonna, when it's greater than, you shade above. All right, we'll go through that. All right. So if I do that, okay. So when I'm doing inequalities, greater than and greater than or equal to is above. All right, less than and less than or equal to is below. When it's solved for y, we talked about literal equations. So when it's y versus mx plus b, you can follow that rule. All right, and then if it has a line underneath, like those two, it's a solid line. And if it doesn't, it has what we call a dashed line because it does not include that in its solution set. All right. So if we have, all right, let's say y is greater than or equal to 1/3 x minus 1. We would start with the y-intercept, which is the -1. The slope then is 1/3, which means I go up 1 and over 3. So from that point, I go up 1 and over 3. Plot that point. I then look at my inequality itself. It has a line underneath. So I connect them with a solid line. All right. And then I look at the inequality itself, which is above. So I would just shade above because there's an infinite number of solutions. All right, that should cover the graphing component. I will look through those modules and see if there's anything else. The one thing I would talk about is if instead of a solid line, it's a dashed line and it's not solved for y. So let's say we have 2x minus 4y is less, we're going to make it just less than, all right, 12. All right, right now at this point in the game, the best thing we can do is solve for y. So I would subtract negative 2x from both sides. Again, this is our little equation, so negative 4y less than or equal to negative 2x plus 12. I'm then going to divide by the inequality's coefficient, y's coefficient, which is negative 4. Remember to divide everything, both the x and the constant. When I do, that cancels. Y, negative 2 over negative 4, negative over negative turns it into a positive, and 2 over 4 reduces down to 1/2 x. And then 12 divided by negative 4 is negative 3. However, when we divide by a negative number, the rule is we flip the inequality. So our final answer for that solve for y would be y is greater than 1/2 x minus 3. I then want to graph that. All right, 1/2 x minus 3 puts me down there. 1/2 puts me up 1 and over 2. All right. The difference is instead of a solid line, you would represent it with a dashed line. All right. And again, it's greater than, so I would shade above it. All right, like I said, that should get you through the graphing component of these two modules. I'll take a look at the systems part, probably put up another video tomorrow. All right, best of luck to you. I hope this helps. Stay safe. All right, and be good.